Hello geometry students, my name is Emigh, and this video is our discussion on section 1.6, angle pairs and their relationships. Adjacent angles are angles that share a common side and a common vertex. They form a linear pair when the non-common sides are opposite rays. All right, so let's start by breaking that down using this figure here. Angles 1 and 2 are adjacent angles, and you can see according to the definition there that they have this common side, it's right here, and they have a common vertex, that one's right there, okay? So these two are considered adjacent angles. I like to think of it as if you open a box of pizza, two pizzas that are right next to each other, two slices of pizzas like this. Well, my pizza's not drawn very well, but let's say this slice of pizza and this slice of pizza. Their angles are adjacent angles because they have one side in common and then they have the common vertex. So if that helps you. All right, angles 3 and 4 are also adjacent angles because they have this common side and the common vertex. But angles 3 and 4 also form a linear pair, and that is because this straight line right here. So it's when the non-common sides are opposite rays. So just think of if you have that pizza again, and for some reason you take this slice of pizza and there's someone else takes all of this pizza. It may be sliced up, but they take it all as one big slice like that. And you take this slice, you guys have taken not only adjacent slices of pizza, because the adjacent angles, but you've also taken a linear pair because your non-common side forms a line, or a straight angle, or half of the pizza, however you want to think about it. Vertical angles are angles that the sides form opposite rays. So in this figure here, angles 1 and 3 are vertical angles, 1 and 3, and that's because their sides are opposite rays. For example, here's the common vertex. This side of angle 3 and this side of angle 1 are opposite rays, as well as this side of angle 3 and this side of angle 1 are opposite rays. Same things with angles 2 and 4. Those are vertical angles. I like to just think of it as anytime you have two straight lines crossing like that, you have two vertical angle pairs. This one and this one are vertical angles, and this one and this one are vertical angles. So vertical angles you should be able to spot really easily, and you should, whenever you see an X like that. And soon we'll talk about how the vertical angle pairs are also congruent. So this measures the same as that, and this one measures the same as this one. It doesn't matter how the lines intersect, two vertical pairs will always form congruent angles like that. Okay. Complementary angles are angles that sum to the measure of 90 degrees. Each angle is called the complement of the other. All right, so let's look at these examples. Angles 1 and 2 right here are complementary angles. We don't know what angle 1 measures and we don't know what angle 2 measures, but we know that if we add their measures together, we get 90 degrees. That right there is the definition of complementary angles. So angle 1 is the complement to angle 2, and angle 2 is the complement to angle 1. This figure right here, angles A and B, those are also complementary angles. It's okay that they're not touching. They don't have to be adjacent like angles 1 and 2 right here were. So these two angles, if you add their measures together, 25 plus 65, you get 90. That makes them complementary angles. Supplementary angles, measures have a sum of 180 degrees. So each angle is called the supplement of the angle, of the other angle. This figure first, angles 3 and 4. We don't know the measure of angle 3 or the measure of angle 4, but figure assumption, we are allowed to assume that that is a line, And so we're allowed to assume that the measure of angle 3 plus the measure of angle 4 equals 180 degrees, and that makes them supplementary angles. So angle 3 is the supplementary angle to angle 4, and angle 4 is the supplementary angle to angle 5. All right, just like above with the complementary angles, C and D are also supplementary angles, and it doesn't matter that they're not adjacent, that they're not touching or have one side in common. If 63 plus 117 are their angle measures, and that adds to 180, which it does, then those are supplementary angles. All right, something you're going to need to remember off this slide, well, you need to remember everything, but something that might help is whenever you hear complement, think 90 degrees, and supplement, make sure you're thinking 180 degrees. All right, we have another defined term here. It's called an angle bisector. And an angle bisector divides an angle into two adjacent angles that are congruent. So just like our segment bisector, remember when we had a segment like this and it was cut into two congruent parts? So this is the knife, if you will, and that cuts the segment into two congruent parts. This right here was called the segment bisector. I like to think of it as the knife that cuts it into two, so think two congruent parts. It's the same thing here with this angle. This is the knife that cuts it into two congruent parts. You can think of that slice of pizza again if it helps. If you have a slice of pizza and you take a knife and you cut it into two congruent pieces of pizza like that, two congruent angles, that right there is called the angle bisector. You have bisected the angle. So referring to this figure here, ray PB is the angle bisector of angle APC, and that angle bisector forms two congruent angles, angle 1 and angle 2, or you can call them APB and BPC. All right, let's use the figure shown to find the measure of each unknown angle. A, find the measure of angle BAC. BAC, oh, that wouldn't be this figure. We must have a different figure. There it is. Okay, find the measure of angle B to AC. All right. And we can do so because ray AC is the angle bisector of the large angle, BAE. And because that is an angle bisector, and because of this geometric code right here, you might have picked up on this geometric code, wherever you see a single arch like that, it's 62 degrees. So whenever you have another single arch, it's also 62 degrees. So that makes our measure of angle BAC 62 degrees. So there are two ways we figured that out. One, definition of angle bisector. Two, the geometric code. Okay. Part B wants us to find the measure of angle BAE. I like to trace that, just make sure I'm understanding the question. BAE is that entire, the large angle you see. I'm going to put the 62 back up here. And so using the angle addition postulate, we can add the 62 and the 62. So we get 124 degrees for the large angle BAE. So it's important to remember that angle measures follow the rules of addition. So you can add their degrees together, no problem, okay? All right, finding angle measures. In the figure, ray Q passing through Y bisects angle RQZ. And we also know that by the geometric code right here. Okay. Find the value of X, then find the measure of angle RQY and the measure of angle YQZ. All right, you see those algebraic expressions. So we know we need to write an equation. We want that equation to have an equal sign because that is what makes it an equation, and we want it to have the letter X in it. So we need to look at this figure and we need to translate it into some kind of equality, some kind of balance with an equal sign between. Okay, well, by the definitive angle bisector, I know that this angle right here has the same measure of this angle right here. So I could set those two algebraic expressions equal to each other. I know that the measure of this angle, like I just highlighted, is equal to the measure of this angle. So I can substitute the 2x right there and the 3x minus 11 right there. And that will be the trickiest part for a while because you have to follow all these new definitions in the geometric code, but it's going to be a very important step, translating between a geometric figure to an algebraic equation. And now that we have done that translation, there it is written up quite a bit nicer. Now just pretend you're back in algebra class and use those algebra skills to manipulate this equation to isolate x or to solve for x. So this first move was subtracting 2x from both sides of the equal sign. That's one way to go about it. And then the last move was adding 11 to both sides of the equal sign. So your result should be x equals 11. I just want to show, I probably would have gone a different route. I'll get to the same result as long as I manipulate the equation following the correct rules. I would have got myself to negative x equals negative 11, and then I would have divided both sides by negative 1, getting me to that x equals 11. So either way, and there are multiple ways you can go about manipulating your equation as long as you follow the rules correctly and don't make any mistakes, of course, you should get to x equals 11. All right, super tempting to box that answer and just move on to the next question. But remember, we have more parts we typically do in geometry. We have to plug that x equals 11 back in right there and right there to solve for the other two angle measures. Plugging it in right here gives us a 22-degree measure, and plugging in right here also gives us a 22-degree measure, and it should, if it gave us two different angle measures, we would know we made a mistake somewhere, because according to the geometric code 1, 2, and the definition of angle bisector right there, these two angles should have the same measure, 22 degrees each. The large angle, should they have asked us for it, would then be 44 degrees using the angle addition postulate. All right. Let's try finding measures of angles, again, through this example. Solve for x and y, then find the measure of each angle. All right, this one's getting a little bit more complicated. I see 4 algebraic expressions this time. I see that these two expressions, these two, contain the letter x, and these two expressions contain the letter or variable y. Okay, so when I go to translate from my geometric figure into my algebraic equations, I would like to find some kind of balance using only the letter x. And then I would like to write a different equation, finding some kind of balance using only the letter y. If I can't do that, then I can work the equations together using our skills to solve systems of equations, which you guys learned how to do in your algebra classes. But I first want to try and get my equation to just have the letter x. So let's see if I can do that. Well, I'm going to erase a lot of this work. I'm just going to focus on this angle here, this angle here. I'm just going to kind of cover this up. Cover it with your hand or cross it out if you printed it, or mentally cross it out. Just try and focus on what you have there with the letter x. I see an adjacent linear pair. I see supplementary angles. I see two angles that form a straight line. That to me says that if I add those two angles together, I will have 180 degrees. And that is how I'm going to translate into my algebraic equation. The 4x plus 8 plus the x plus 47 will equal 180 degrees. Let me see if I have that written down nicer for us. There it is. X plus 47 plus the 4x plus 8 equals 180 degrees. Now we can just pretend we're back in algebra class, use our algebraic skills to manipulate this equation. So that first step was combining like terms. There we use the subtraction property of equality. There's the word property, that's what I was looking for. Now we're going to use the division property of equality, and we get x equals 25. Plugging, we're not going to plug that back in yet. First, we're going to write our equation with the y in it, and it's the same strategy. Our two angles that contain expressions with the variable y in it form a linear pair. They are supplementary angles. That means that their measures sum to 180 degrees. So one of the angles plus the other angle has to equal 180 degrees. All right, now that we've done that translation, we manipulate the equation. That first step there was combining like terms. Then subtracting 30 from both sides of the equal sign is called the subtraction property of equality. And last, we divide both sides by 5. Division property of equality gives us y equals 30. All right, so we found x, we found y. We're going to plug those back in to find the measure of each of the 4 angles. So starting with the x equals 25 going right there. 4 times 25 is 100 plus 8 more. So I have 108 degrees for this one here. I can continue plugging stuff in, but I could also use the supplementary angles rule that says 180 degrees. This right here would have to be 72 degrees. 108 plus 72, that's necessary to get to 180. So that works. I could then plug y in, or I can notice that I have supplementary angles at the top here as well. So this has to be 72 degrees also, because these two have to form a straight line. And then these two right here have to form a straight line, or they do form a straight line. So they're supplementary angles also. So I could get the 108 like that. If you didn't pick up on any of that yet, that's okay. You can just take your x equals 25, plug it in right there. You'll get 108. Plug it in right there, and you'll get 72. You can take your y equals 30, plug it in right there to get 108, and plug it in right there to get the other 72. And that will conclude our discussion on section 1.6. My name is Emigh. Thank you for joining me, and I'll see you next time for our discussion on section 1.7.